सुन ले लारिया वे आलोक मेरे इतिहास दे ऐसी जादे दे दूंगी
Good evening, everyone. I invite Gurvinder sir to conduct this session.
Good evening.
Hi, hello everyone. Good evening. I hope I am audible.
Yes,
Yes,
you
you
are.
are audible.
Okay.
Good evening, sir.
Hi, hi. Hello,
Good
good
evening,
evening,
sir.
everyone. Hello, good evening.
Good evening, sir.
Hi, hi, good evening. Hello. तो करते हैं फिर स्टार्ट. सो चलो ठीक है. सो देखें पहले तो कौन कौन आया है. सो टुडे वी विल बी प्लेइंग अ वेरी स्मॉल गेम. मतलब नॉट एक्चुअली अ गेम बट जस्ट अ स्मॉल स्टोरी. So we have all of you, like I just wanted to play a game with all of you. So what I did, I arranged all of you in a line, okay, like this. We have a line, you all boys and girls. I arranged in a single line, and in the starting of the line, I have a smart boy, है ना. एक smart boy को सामने खड़ा कर दिया, और इस line के लास्ट में मिस्टर बीन को खड़ा कर दिया. स्मार्ट
Yes,
बॉय,
sir.
ठीक है. समझ, गॉट दिस? क्या
Yes,
हो रहा
sir.
है
Yes,
गेम में?
sir.
समझ आ रहा है क्या हो रहा है?
Yes, sir.
Yes, sir.
ठीक है, ठीक है ना. तो ऐसा तुम सबको खड़ा कर दिया, इधर मिस्टर बीन, इधर स्मार्ट गाय. ठीक है.
Yes,
तो
sir.
अब
हाँ,
लाइक
sir.
है ना. सो व्हाट वी यूज्ड टू डू इन आवर चाइल्डहुड क्लासेस, जब हम छोटे होते थे, व्हाट वी यूज्ड टू डू, वी व्हेन वी यूज्ड टू स्टैंड इन अ लाइन एंड समवन यूज्ड टू पुश अस फ्रॉम बिहाइंड. तो हम लोग क्या करते थे, we used to push the other person, the next in line, the person who is in front of us in the line, and we used to say यार पीछे वाले ने धक्का दिया था. सब करते थे ना.
Yes.
Everyone used to do this, right? Whenever
Yes,
someone
sir.
pushed us in a line from behind, we used to push the other person, the person in front of us, and we used to say that यार ये पीछे वाले ने धक्का दिया, तो इसलिए मैं तुमको धक्का दूंगा. So this is the same thing. Okay. So what is happening is, so I am just assuming a few names. देखें भाई कौन कौन आया आज. तो चलो, ये रही आश्रिता, ये मनोज, ये रक्षित, और कौन कौन है आज? ये गायत्री, ये मेधा, प्रीति, ठीक है, एक और पवन. ठीक है. सो लाइक दिस वी हैव गॉट quite some people in the line, and then in the last we have got Mr. Bean. Okay, in the last we have got Mr. Bean. So each of us, okay, so Ashrita, Manoj, Rakshit, Gayatri, Pavan, okay, Preeti, all of they have told me one thing. They have told me one common statement. Okay, there is one common statement that all of them have agreed. They have told me that if someone pushes them from left, okay, if someone to their left is pushing them, so they will make sure that the person to their right also falls down. Okay, just like we used to do in a game. So every person, like all people in line, have agreed that if they get pushed, okay, if they get pushed, they will push the next person in line. Fine. Okay, so like for example, here we have Rakshit. Okay, so Rakshit ने बोला है, Rakshit has told me that if Medha pushes him, if by any chance Medha pushes Rakshit, so Rakshit will make sure that Gayatri will also fall down, that he will push Gayatri. Similarly, Pavan has told me that if Gayatri pushes her, so he will make sure that Manish also falls down. Okay, the same goes for every person in line. Okay, तो यहाँ खड़ा smart guy. We have this smart boy over here. So smart boy has thought. Smart boy, what did smart boy do? He wanted all of you to fight with each other. So what he did, he used a very clever trick. So what smart guy did was, smart guy gave a push to Ashrita. Okay. So what happened? We have this first guy, smart boy, standing here. So this smart boy gave a push to Ashrita. So can I say कि सबका मोए मोए है? Moe moe confirmed? सबका everyone in the line will fall down. Can I say that?
No, sir.
Okay. Can you tell me why?
Because in last, Mr. Bean is standing.
Like what I'm trying to say is everyone in the line will fall down, and at last Mr. Green will also fall down. Can we infer this? Can I infer that Mr. Bean will fall down? See,
Maybe.
just look back into the statement. See, everyone in the line has agreed that if they get pushed from the left side, so they will push the person standing next in line to them. Okay. So basically, what will happen is this smart boy has pushed Ashrita. Now Ashrita has told me कि सर पहले मैं तो किसी को धक्का नहीं दूंगी, but if smart boy pushes me, I will make sure that Manoj also falls down. Okay. Similarly, what has Manoj told me? See, I'll just explain you again. Okay. I will write the complete name so that it's easy to understand. So see, this is Ashrita. Okay. This is Ashrita. This is Manoj. Okay. This is Rakshit. This is Gayatri. This is Pawan. Okay. So see, what is happening is smart boy has pushed Ashrita. Smart boy has pushed Ashrita. So now Ashrita won't stand like that. है ना? आश्रिता को धक्का लगा है, so अब उसको भी गुस्सा आ रखा है. So what she will do? She has been pushed by smart boy. So now she will also push the person next in line. So she will push Manoj. Okay. Now Ashrita has pushed Manoj. So now Manoj is also getting pushed. So he has also agreed that if he will get pushed, so he will also push the person next in line. So he will push Rakshit. Similarly, we have Rakshit. Now Rakshit is getting pushed. He is also angry. He will push Gayatri. Again, Gayatri has also told me that if she is getting pushed, she will also push the person next in line. So Gayatri को भी गुस्सा आया, उसने पवन को धक्का मारा. So can I say that like this, the last person, Mr. Bean, will also get pushed. He will also fall down. Can I say this?
Yes.
Yes, sir.
Yes, sir.
Can we say that the person that is last in the line will also fall down just by one single push?
Yes, sir. Yes, sir.
Sure, because
Yes, sir.
everyone has agreed. क्योंकि ना सबने, everyone in line has agreed to this one common statement that if I am getting pushed, I will push the person next in line. Okay. So can I say that everyone will get pushed
No,
Yeah.
sir.
just
Smart
by
boys
one
will
single
remain.
push? Sorry?
Smart boy. See, smart boy never. Smart boy never get pushed.
Yeah. Like he's just the one to initiate. He's smart, na actually. So he just wants all of you to fall down. His intention is to make all of you fall down. Fine?
Yes, sir.
Okay, great. So, okay. तो चलो सबका हो गया मोए मोए.
नहीं, sir.
Okay, why? Can you tell me? Why do you think so?
We are not in line, sir.
Uh, like I don't get your point. You are not in line means?
Sir's point is everyone in line will get followed, not you.
Okay. अच्छा, you, okay. Okay. नहीं, like I am talking about you all, like all the students. Okay, so I can say that everyone in line will fall down, right?
Yes, sir.
Okay, great. Right? मोए मोए confirm.
Yes,
सबका
sir.
मोए मोए होगा. Confirm
Yes,
ना?
sir.
Yes,
Okay,
sir.
great.
Sir.
Okay. Okay, great, great. great. चलो तो मिस्टर बीन गिर गया ना नीचे. आ गया मिस्टर बीन नीचे इधर गिर के.
Yes.
ठीक है, गिर गया मिस्टर बीन. चलो गिरा दिया तुमने मिस्टर बीन को. ठीक है. ओके, सो ग्रेट. मिस्टर बीन भी गिर गया नीचे. सो जस्ट दीज वर टू स्टेटमेंट्स. So everyone in line had agreed that if I fall down, I will make sure that the person next in line will fall down. And the other statement was that the first person will need a push. The first person should be pushed by someone, some external force, right? So just write down your topic for today's discussion. ठीक है? Does anyone know principle of mathematical induction? What does principle of mathematical induction say? Okay. So basically, principle of mathematical induction is a method of proving any
Yes.
given statement.
Yes, sir.
Okay, great. Must have learned it in college, right?
Yes, sir.
Yes, sir.
Anyways, yeah, it is not a part of JE syllabus, so that is why I'll just be taking one single class. Okay. So just like what was happening here. So what was happening here is you are pushing the first person in line, and every person in line has agreed that if they get pushed, they will make sure the other person is getting pushed. So what was happening was that the last person in line, Mr. Bean, was falling down. Okay. Mr. Bean was falling down. So the same thing will happen here. We will use the same method, principle of making people fall down, making numbers fall down. Okay. How we will make numbers fall down in the same way? So you need to prove any statement for any given natural number. Okay. So there are just two basic steps that you follow. Two steps for using PMI. Okay. What are the two steps? First is make sure P of 1 is true. Okay. So for example, I have a statement. P of n, like P of n, that stands for any natural number n. Okay. So there are just two steps that you need to keep in mind. What? First of all is P of 1 should be true. Okay, P of 1 should be true. Or rather say P of first first term should be true. Okay. After that, what will you do? Assume P of k is true for any k belonging to natural numbers. Okay. Third, using the second statement, prove P of k plus 1 is true. So see, no need to like by heart or no need to मतलब बहुत ज्यादा डिटेल में जाने की जरूरत नहीं है. It is very easy. P of 1 is true. Okay, so like for example, I'll just give you an example. So I need to prove a statement. So I have a statement. Statement is P of n. Okay. So what is the statement telling me? This statement is telling me 1 plus 2 plus 3 plus 4 so on till n is equal to n into n plus 1 by 2. Okay. We have also proved this statement. This is a statement. Okay. We have proved this statement using the sum of arithmetic progression, right? in class 10th. We have proved this statement. Now it's time to prove the same statement using principle of mathematical induction. So what will we do? There are three steps you need to follow. There are just 3 steps you need to follow while engaging principle of mathematical induction. So what will you do? Obviously, the first step number 1.
Substitute 1 in
1, exactly. So can you tell me what is 1? P of 1. What will be my statement P of 1?
1.
Left side and right side. Okay, so LHS and RHS. So my left hand side will only be 1 because you have to take the sum only till n, right? And n is equal to 1. Can you tell me what will be the right hand side?
1, sir.
What will be the right hand side? Right, it is 1 into 2 divided by 2. It is 1,
Yes, sir.
right? So my LHS is equal to RHS. So that
Yes.
means my P of 1 is true,
Yes,
right?
sir.
Okay,
Yes,
my
sir.
P of 1 is true. So now tell me, how will I proceed further? How will I proceed further?
Substitute K in place of N.
Correct, correct. So my step 2 is assume P of K is true
Yes, sir.
for K belongs to any natural number, right? So if P of K is true, I'm basically trying to say that 1 plus 2 plus 3 plus 2, so on till K is equal to K into K plus 1 by 2,
1 by 2.
right? Now using this statement,
P of K plus 1.
P of K plus 1.
yes, exactly. Right? Using
Yes,
P
sir.
of K, using
Yes,
P
sir.
of K, I need to prove that P of K plus 1 is true. Fine.
Yes, sir.
Right. So basically, I have this statement. I am assuming this statement is true. I have assumed that this statement 1 is true. Okay. So using this statement, I have to prove that P of K plus 1 is also true. First of all, can you tell me what is P of K plus 1? What will be P of K plus 1? What will be that?
K plus 1, sir.
P of K plus
Yes,
1 in
it will
K.
be till. Yes, correct. It
Until
will be till K plus 1. And what will be my right side?
K plus
K
1
plus 1 into K plus 2
K
by
plus
2.
1.
K plus
Correct.
2 by 2.
Correct. Yeah, it is correct. No need to worry. So yeah, absolutely correct. 1 plus 2 so on till K plus 1 is equal to K plus 1 into K plus 2 by 2. Correct. So using this statement number 1, I need to prove this second statement to be true. So it is very easy to think, like you have this statement 1. So in statement 1, add K plus 1 both sides, right? In LHS and RHS, add K plus 1. So in LHS, I already have 1 plus 2 plus 3 so on till K. Okay. And this is K into K plus 1 by 2. Fine. So I am
Yes.
asking you that on both sides, just add K plus 1. So when you take the sum, it is 1 plus 2 plus 3 plus so on till K and K plus 1, right? And on the right side, it is K into K plus 1 by 2 plus K plus 1. Fine. So you take K plus 1 by 2 common. So it is K times how much? 2,
2
right?
plus 1. 2 into K plus 1.
Yes.
2
So it is
small.
basically K plus 1 into K plus 2 by 2.
Yes, sir.
Yes, sir.
Fine? Fine.
Yes.
So what is my left hand side basically? My left hand side was 1 plus 2 plus 3 so on till K plus 1, right?
Yes,
And
sir.
my right hand term is equal to. So can I say that I have basically proved that P of K plus 1 is true?
Yes, sir.
Right? I have proved it. So since I have completed this P of k plus 1 wala part, so I can basically say that my P of n is true for any n belonging to natural numbers. How it has happened, I'll just explain it again. See, I'll just explain it again. See, basically what is happening is I have a statement P of n, okay? I have a statement P of n that is true for any, that I want to prove it, that it is true for any natural number n. So basically what I will do is first I will take the case of n is equal to 1. Okay. So basically what is n is equal to 1 case? N is equal to 1 is basically in the line it is denoting me. It is showing me that the smart guy has pushed the first person in line. Okay. This is what it is showing me, that the first person in line is being pushed. That is what is meant by n is equal to 1. Then what I will do, I will assume that my statement is true for P of k. And assuming that my statement is true for P of k, I will prove that it is true for P of k plus 1. So what does this statement basically mean in the line? In the line, it means that if my kth person in the line is being pushed, P of k is true. If P of k is true, that means my kth person in line is being pushed. Okay. So P of k plus 1 is true. That means k plus 1th person is also being pushed. This is what it means. Now I have written the relation between what these numbers mean and what it means in the line. So n is equal to 1. P of 1 basically means that the first person is being pushed. And then when I assume it for P of k, so basically I am assuming that my kth person is being pushed. And using this statement, when I am proving that P of k plus 1 is true, so basically what I am saying is that if my kth person is being pushed, he will make sure that the person next in line, that is k plus 1th person, is also being pushed. So I hope there is no confusion between kth and k plus 1th. Like it is just a number. K is any natural number. K is any natural number that you can think of. So what it means is that if any number k person in the line, k can be anything you just wish for it. 9, 10, 11, 15, 20, 100, 1001, anything. So if my kth person in the line is being pushed, he will make sure that the k plus 1th person, or rather say the person next in line to him, to the right, is also being pushed. So with that phenomenon, everyone will fall down. How? Again, I can just easily prove it. See, if my kth person is falling down, he is making sure that my k plus 1th person will also fall down. And what is happening is in the first case, my first person is falling down. So my first person will make sure that my second person also falls down, right? Similarly, my second person is falling down. So my second person will make sure that my third person is also falling down. My third person is falling down. He will make sure that fourth person will also fall down. Fourth person is falling down. He will make sure that fifth person will also fall down. In such a way, my whole line will fall down. Sabka moe moe. Fine. Did you get the concept behind it? Why principle of
Yes, sir.
mathematical induction basically works? It is a brilliant way to prove something. Like it is a great way in higher level of mathematics. When you go to engineering, there will be several proofs that we will be doing through mathematical induction, that like there is no other way to do those proofs. So it is a very brilliant method actually thought by mathematicians, that how, and it is valid, right? It is logical. There is logic behind it. If you see clearly, if my first thing is falling down, and using my kth element, I can make my k plus 1th element fall down. So it is a brilliant way to like substitute the value of k for different values and make the whole line fall down. Correct? Is it understood, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Bhaskar, Medha, Varshini, Preeti, Pavan, Manoj, Shravani,
Yes.
Gayatri, Bhavna, Preeti. Is it fine?
Yes, sir.
Yes, sir.
Okay, great. Great. Good to hear that. If you have any doubt, you can ask like what why it is happening or something. So like, see, we till now we have learned many methods. Okay, when we were in our earlier classes, we have gone through many methods of proving statements in mathematics, right? Till now we have like we used to take sum of arithmetic progressions. We used to do like many things, right? So just see your principle of mathematical induction as a method. It is a method to prove a statement. Okay, so just there are three basic things that we are doing here. What? We are making the first person in line fall down, and then assuming that my any kth person in line has fall down, using that I will make my k plus 1th person also fall down. Okay, so just moving ahead with this one, just a few more proof. So I need to prove that 1 plus 2 plus 3 so on till n squared is equal to n into n plus 1 into 2n plus 1 by 6. Okay. So tell me, how can I do it? Tell me, what are the three steps? What are the three steps of PMI? What is the first step of PMI?
N is equals to 1, sir.
N
Yes,
equal.
correct. Correct. P of 1 basically, right? So I need to prove P of 1 first. So P of 1 ले लिया, ये LHS ले लिया, and this is RHS. Okay. So LHS, in LHS, N is equal to 1. So 1 है, it is just 1. Or in this side it is 1. So 1 into 2 into 3 divided by 6. So it is also 1. So
Yes, sir.
basically P of 1 is true. Okay, P of 1 is true. Now, after that, what will be my next step?
P of K, sir.
P of K.
Assume. Yes. Assume that P of K is true. Okay. Assume that P of K is true. So if P of K is true, it basically means 1 square plus 2 square, so on, till K square
Where
is
is
equal
it?
to K into K
K
plus
plus
1 into 2 K
K plus
by
1
6,
by.
right? Correct?
Yes, sir.
Now, using this statement 1, I want to prove P of K plus 1 is also true. So what can I do? Add K plus 1 whole
K
square on
plus
both
1.
sides,
Yes, sir.
right? So when I add it, it will basically be 1 square, 2 square, so on, K square and K plus 1 square, right? Similarly, when I add it on this side, so it is basically K into K plus 1 into 2K plus 1 by 6 plus K plus 1, correct? So this thing, left side, will remain as it is. Now I will take K plus 1 common. So it is K plus 1 by 6 into, it is 2K square plus K plus 6K plus 6. You can just go through with the algebra, right? This algebra is clear, right? So it is
Yes,
K plus 1 by 6 into 2K square plus 7K plus 6. 2K square plus 7K plus 6. अब इसको क्या करोगे? I have 2K square plus 7K plus 6. So 2 into
Factor.
6, it is 12. 4 and 3. Correct. So my factors will be 4 and 3 basically. So this is basically 2K into uh, k plus, अच्छा ठीक है, 2k मतलब just take it
Sir,
k only.
K common.
K is
Yeah,
common.
it
Yes.
will be k. So it is k into 2k plus 3, right?
Three.
Plus 2 into 2k plus 3. So it is
Yes.
basically k plus 2 into 2k plus 3. Correct?
Yes, sir.
So it is k plus 1 by 6 multiplied by k plus 2 into 2k plus 3. And this my left side will remain the same. It is 1 square, 2 square, whole on till k plus 1 square. So if you substitute here k plus 1 in place of n, if you substitute k plus 1, so you will get this thing. So hence prove that p of k plus 1 is true. This thing is my basically k plus 1. If you look clearly over here, in place of n, if you substitute k plus 1, so I can just do it for you. So n की जगह k plus 1 डालना है. So it is k plus 1 और n की जगह, so it is k plus 2. Okay. Then 2 into k plus 1 whole by 6. So this thing will be equal to k plus 1, k plus 2, and it will be 2k plus 3 whole by 6. And it is the same thing that we are getting there. So basically it is p of k plus 1 only. So I have proved that p of k plus 1 is true. And once this is done, hence prove that p of n is true. So this is all about my principle of mathematical induction. That how I am using principle of mathematical induction to give you a proof. Okay. How there are other methods to give the same proof. Yes, yes. Like the previous question we have done, na? See, the previous question that we have done. I can also prove this thing, like 1 plus 2 plus 3 plus 4 and so on till n into n plus 1 by 2. So there are other methods to prove this thing also. You must have given a proof of this using sum of arithmetic progression in class 10. Okay. In class 10, we used to do the proof of this thing using sum of arithmetic progression. So the same thing we are proving today using principle of mathematical induction. Similarly, like this thing we have over here. So in the chapter of sequence and series, there is a special technique also. Achha, okay, I did a mistake here. Sorry. It is square, like sum of all squares. Okay. So it is 1 square plus 2 square plus 3 square whole on till n square. Okay. Yeah. So there are other methods also. But what will happen in higher mathematics, many a times you will be required. Okay. There will be some cases where you need to prove something and there is no other such proof available. PMI is the only proof. So for that cases, it is important to learn how proofs are done using principle of mathematical induction. Fine. So just one last proof before we move ahead. So we have a plus ar square, ar cubes, so on till a r raised to n. Okay. A into r into n plus 1 minus 1 by r minus 1. Fine. This is the proof that you need to do. So basically what the proof is telling, that a and r are any real numbers. So basically what you are doing is you are just adding. You are just adding the numbers. Okay. A plus ar square whole on till n powers. N powers. Okay. So okay. So चलो करते हैं फिर इसको. So can you tell me how what will be the first step of this proof? Can you tell?
P
Can
of
anyone?
1.
Yes,
N is
correct. P of 1. We need to prove P of 1, the first term. So can you tell me what will be the first term? Like what will be the left hand side and right hand side of this?
AR, sir.
It will only be AR. Just
AR.
Yes, sir.
it will not just be AR.
AR
See,
power 1.
like
Sir.
Power 1.
no, no. Like what I'm telling is, uh, see, what is happening is
Sir,
Hello, sir.
yes, Vignesh.
So what about Max class? It had been ended now.
Yeah, no, like sir has ended, like sir has completed the talk.
No, sir.
Yeah, got disconnected perhaps. So I just couple what? I was excuse me, sir.
Yes, yes, sir.
Yes, sir. Your screen was not visible, so I thought any
Yes,
problem with
yes,
the
yes.
connection.
Yes, yes, there was problem with connection.
All right, sir. All right.
Okay.
Sir,
So, hello. Yes.
in numerator we get r square minus 1 square. It means a square minus b square.
Yes, yes, true. Like, first of all, just clear me out the with the LHS. Can anyone tell me what will be the LHS for P of 1?
Ar.
P of n basically. No, okay. So just there is a bit of confusion. Uh, so I'll just like clear it out again. So this thing is my P of n. Okay, my P of n is basically telling me that if you take the sum from a r raised to 0 plus a r raised to 1 plus a r square a r cube whole on till a r raised to power n, where n is this thing. Okay, n is this last number. So basically, I have to take my sum till a r raised to n. Then my sum will be equal to this thing on the right side. Okay. So now I am telling you what is P of 1. So basically, what is happening is you have to take the sum from a r raised to 0 till a r raised to n. So basically, my left hand side will be a r raised to 0 plus a r raised to 1. Okay, because I can't take my sum till I can't just say that AR is my term because I have to take my sum from AR raised to 0 plus AR1 plus AR square plus AR cube whole on till AR raised to n. And I am putting my value of n as 1. Virtually, no, it is not an arithmetic progression. It is actually called a geometric progression. So first of all, just understand why my P of 1 is actually being equal to AR raised to 0 plus AR raised to 1. So it is basically A plus AR. Okay. Because I have to take my sum. Like, what is my P of n telling me? My P of n is telling me that, sir, whenever you take the sum from AR raised to 0 plus AR raised to 1, so on till AR raised to n. Okay. Whenever you take the sum till AR raised to n, then your sum will be equal to this thing on the right side. So if I have to take my P of 1 statement as P of 1, so I will replace my n with 1. So basically, I will have to take my sum till AR raised to 1. So basically, my sum will be AR raised to 0 plus AR raised to 1. So it will be equal to A plus AR. And then moving on the right side, it will be A into R square minus 1 by R minus 1. So this thing, it is basically equal to R into R plus 1, R minus 1 by R minus 1, right? A square minus B square is equal to A plus B into A minus B. तो r minus 1 ने r minus 1 को काट दिया. So this thing is basically equal to ar plus a. So can I say that my RHS and LHS are equal?
Yes, sir.
First of all,
One
has
second.
everyone understood? Yeah, see. No worries. So basically, what my P of n, my statement for any natural number n, it is telling me that, sir, you take the statement, you take the sum ar raised to 0 plus ar raised to 1 till you need to take the sum till ar raised to n. Okay, where n is the natural number that is given to you. So I have to prove P of 1. So when I am taking the sum P of 1, when I'm considering the statement P of 1, so I will have to take my sum till AR raised to 1. So basically my LHS will be AR raised to 0 plus AR raised to 1. There will be two terms because I have to take my sum till AR raised to N. My last term of summation should be AR raised to N and my N is equal to 1. So it will be basically AR raised to 0 plus AR raised to 1. Similarly, when I move to the right hand side, I substitute N is equal to 1 here. So it is A into R square minus 1 by R minus 1. So I get my LHS and RHS and equal. So basically, if my LHS is equal to my RHS, I can say that my P of 1 is true. Okay. So if my P of 1 is true, what will I do? What will be my next step? Can anyone tell me what will be my next step?
P of K.
P of
Ah,
K
yes,
Assume that
correct. Assume that P of K
is
is
true.
true. Okay. So if P of K is true, it basically means AR raised to 0 plus AR raised to 1 plus so on till AR raised to K is equal to this thing. A into R raised to K plus 1 minus 1 by R minus 1. Okay. Now using this statement, I have to prove that P of K plus 1 is also true. Okay. Using this statement, I need to prove that my P of K plus 1 is also true. So now I will just go through with my P of K plus 1. So can anyone tell me what will be my P of K plus 1? I'm just writing my P of K plus 1 first. So basically my P of K plus 1 will be AR raised to 0, AR raised to 1, so on till AR raised to K plus 1, right?
K
My
plus
last term will be, and similarly here, it will be R raised to K plus 2 minus 1 by R
Right?
minus 1, right?
Yes,
Because
sir.
in K, in place of K, I will need to put K plus 1. So this will be my thing. So can you tell me how from P of K I can come to this statement? I have this statement, like I am assuming that my this statement is true already, okay? This statement number 1, I am assuming that my statement number 1 is true. So since my statement number 1 is true, do I have a method? Do I have a method to come to statement number 2 directly? What can you do?
So from AR not 2 and AR raised to K is A into R K R2
Ah, correct.
R7.
Like basically what I have to do is I can add AR raised to K plus 1 on both sides. Okay. So in statement 1, add AR raised to K plus 1 on both sides.
both sides.
Okay. So basically my left hand side will become this. AR raised to 0 plus AR raised to 1 plus so on. AR raised to K plus AR raised to K plus 1. Okay. This thing. And my right hand side will be equal to A into R raised to K plus 1 minus 1 by R minus 1 plus AR raised to K plus 1. Fine,
Yes, sir.
right? So I will just try to common out. I will try to common out. So it is A into R raised to K plus 1 minus 1 by R minus 1 plus R raised to K plus 1. ठीक है, now इसको करो, like I need to solve it ना, so cross multiply. So it is R raised to K plus 1 minus 1 plus R raised to K plus 2 minus R raised to K plus 1 whole by R minus 1. So it is basically A into R raised to K plus 2 minus 1 by R minus 1. Right? So basically, and So basically, I can say that P of k plus 1 is right, because this
sir.
thing is basically equal to P of k plus 1. If you look clearly,
Yes, sir.
it's basically P of k plus 1. So like if my P of k plus 1 is true, I can simply say, अगर मेरा P of k plus 1 true है, so I can just simply say one more thing, that my P of n is true.
Yes, sir.
N belongs to all natural numbers, right?
Yes,
So it
sir.
was a very, ठीक है, basic सा proof था. चलो, so just moving ahead with one more special type of problem. So what this type of problem is telling me, it is telling me P of n. Okay, P of n factorial. Achha, first of all, does anyone know what is n factorial? Okay,
No.
no worries. No
No,
worries,
sir.
no worries. So 1 into 2 into 3 into so on till n. Okay. Okay, this thing is basically greater than. Okay. It is basically greater than 2 raised to n. Okay, when my n is greater than or equal to 4. So what has happened now? What has happened now? Just look. अभी क्या हो गया है? My
N is
first
two.
element has changed. No, like my first element has changed. Now this statement is only true. This statement is only true when n is greater than or equal to 4. So can you tell me what will be my first statement of proof?
4.
Now, yes, correct, absolutely correct. Now I won't be going for P of 1. अब मैं P of 1 के लिए नहीं जाऊंगा. I won't be running for P of 1. Why? Because P of 1 it is not true. Now my proof, now my statement of proof is starting from 4. N is equal to 4. So my first step will be P of 4. Okay. So चलो LHS और RHS बता दो. So can you tell me what will be my LHS? It is 1 into 2 into 3 into 4. So it
Yes.
is 24, right? And can you tell me what will be my right hand side? 2 raised to 4. What is 2 raised to 4?
24.
2 raised to
24.
4 is 24.
15,
No, sir. 16.
16, sir.
हाँ, yes. अरे भाई 2 raised to 4
Sir.
24 किसने बोल दिया?
Sorry, sir.
No worries. So can I confirm that my P of 4 is true? Because my 24 is greater than 16, right?
Yes, sir.
Array, it is not equal. Just look, there is an inequality sign. Greater than sign is there.
Yes, sir.
Fine?
Yeah, sir.
Okay, great. So again, P of 4 आ गया. Because P of 4 was my starting point. My starting point has changed now. Earlier, my starting point was 1. Now it is 4. Okay, so that is why the first statement that I have proved is P of 4. So again, what will I do? I will assume P of k is true. So if P of k is true, I can basically say 1 into 2 into 3 into 4, so on till k is greater than 2 raised to k.
Okay.
Fine. So now using this statement, I need to prove that my P of k plus 1 is also true. So can anyone tell me what is my P of k plus 1? What will be my P of k plus 1? It will basically be 1, 2, 3, so on,
3,
k and
K,
k plus 1,
K plus 1.
Yes.
right? Should be greater than equal to 2 raised to k
2
plus
plus
1, right? I need
Yes,
to
sir.
prove this thing. So chalo, socho, like just think how from my statement 1 I can come to this statement. Just think how from my statement 1 can I come to this statement.
2K into K plus 1, sir.
2k into k plus 1, like what?
Sir,
Like
equation.
basically
Adding A plus 1 on both sides.
adding. Are you sure adding will work?
Yes, sir.
Applying with
Actually, like it is
K.
multiplied, no? 1 into 2 into 3 into 4, so on till k. Like they are getting multiplied. Similarly, this
Yes.
is also getting multiplied. So what will you do now? So I'll just show you one.
Multiply
Okay,
is
no
k
worries, no
plus.
worries. Okay, see. I
Multiplying
have
k
1 into 2 into 3 into so on till k, okay? And this thing is greater than 2 raised to k. Fine? This thing. Fine? Can I also say one thing? So I'll just consider this thing as my statement 2. Fine. I can also say one more thing. That my k plus 1 is greater than 2. Can I say this thing? Is
Yes,
my
sir.
third statement also true? My k plus 1 is also greater than 2. Can I say this thing? Just confirm everyone,
No,
please.
sir.
Is my k plus 1? Okay, why?
Because second
Can
equation is having more numbers.
more numbers? No, I am only talking about my number k plus 1. You choose any real value of k, any natural value of k. Can I say that my k plus 1 is greater than 2? 2 is just a constant 2, not the statement 2. Just number 2. I'm talking about number 2.
yes, sir.
True, right? Both of these my statements are true.
Yes, sir.
Correct?
True.
So just think about this. Okay, just think about this. I have 4 numbers. A is greater than B and C is greater than D. So can I say that my A into C will be greater than B into D? Sone pe suhaga,
Yeah, sir.
cherry on
Yes,
the
sir.
top, cherry on the cake, right? Because this one is greater than
Yes.
this one is greater than this one, and both of these are getting multiplied, right? So what I'm saying is multiply 2 and 3. Multiply 2 and 3 on either side, like this thing with this and this thing with this. So what will happen? My left hand side will basically be equal to 1 into 2 into 3, so on till k into k plus 1, right? And what will be my right hand side? It will be 2 raised to k into
Into
2,
2.
right? So what is it basically? What will be my right hand side? It is basically 2 raised to k plus 1.
Yes, sir.
So if I look clearly at this statement, what is my statement this? What is it is basically p of k plus 1, right? See, it has become p of k plus 1, right? So my p of k plus
Yes,
1 is
sir.
true. So if my p of k plus 1 is true, my p of n is true. Fine? Has
Yes, sir.
everyone understood this?
Yes.
Just make
Yes,
sure,
sir.
if you have any doubt, just ask me. What is happening is I have to convert this p of k, okay, p of k to k plus 1. But the issue is I have an inequality sign. Earlier, what was happening is I could have just easily multiplied k plus 1 on both sides and got it. But that was not possible. That is not possible here because I have inequality sign. So in order to like how I could have thought about inequality sign. So what I did was I used one more property of inequality of multiplication. Number is greater than this number, and if both of these are getting multiplied, so I can just use one more trick of inequality. So k plus 1 is greater than 2, so I'll just multiply 2 and 3. So using that, I got this. Fine?
Fine, sir.
Any issues?
Yes,
No,
sir.
sir.
Yes, sir.
देख लो कोई डाउट है तो.
मैं से समझ आ गया.
Okay, great. Fine. So moving ahead, just one more last type of problem that you may encounter in your college exams. After this, I'll be ending the session. So I need to prove something like P of n. Okay. So what is my P of n telling me? It is telling me that 4 raised to n plus 15n minus 1 is divisible by 9 for all n belonging to natural numbers. ठीक है, 4 raised to n plus 15n minus 1 is divisible by 9 for all n that belongs to natural numbers. So can you tell me what will be my first step?
N equals to
N equal to
P of 1,
हाँ
sir.
करेक्ट, P of 1 बेसिकली, राइट. सो चलो P of 1 है, LHS RHS कर देते हैं. LHS सॉरी RHS तो है ही नहीं इसमें, सो P of 1 ही है बिकॉज इट इज डिविजिबिलिटी ना. सो चलो बता दो, इट विल बी 4 plus 15 minus 1, right? So
yes,
15 plus 3, 18 basically, right?
Yes, sir.
18. So 18 is divisible by 9, right?
yes, sir.
Right? So that means P of 1 is true. So if P of 1 is true, what will be my next step?
P of K.
P of
P of
K,
K.
Right. Assume that P of K is true. So if P of K is true, I am basically assuming that 4 raised to K, okay, P of K. Basically 4 raised to K plus
plus
15K
minus
minus
1
1 is divisible.
by 9.
Yes. Okay. And using this statement, I want to prove that P of K plus 1. So basically 4 raised to K plus 1 plus 15 into K plus 1 minus 1 is also divisible by 9. I need to prove this thing. So what can I do? I will assume this statement to be my second statement. Fine, I can do that, right? I can do this thing, right? I'll just assume my statement is my second statement. So how will you proceed with this? So what I can do is, see, I have 4
Divide
raised
2
to
by
k. Like, how will you divide 2?
second equation by first equation.
No, like that will be really complex because it will like it is not for sure now that this divided by this will result into an integer only. You are not sure that when you divide both of these, so they will not necessarily give you an integral value. So you will lead yourself even further. So no worries, there is just like a very standard method. See, the problem, like one thing I am telling you, this chapter is not a part of JEE Main or JEE Advanced syllabus. Okay, I'm completing it because it is a part of your college syllabus. So we have to do it. So every problem that comes in your college level or in your boards level, it will have a like standardized method of solving. Okay, you don't have to apply much of your brain. There is just 3 methods that you have to use. There are just 3 methods. Okay, so if you can just easily remember those also if you want to. So it is very easy. So what I can do is, see, I know 4 raised to k
Into
plus 15k minus 1 is divisible by 9. Okay. So if it is divisible by 9, what I can do, I'll assume it to be 9 times lambda 1, where lambda 1 is a natural number, right? I can say this thing. Can I can I write something like this? We used to do it in class 10th also, if you remember. When it was given to us that any given statement or any given number on left side is divisible by another number. So we used to write it like this, right? If it was divisible by 10, we used to write it as 10 lambda. If it was divisible by 9, we will write it as 9 lambda. Fine. I can write it. Write 4
Yes,
raised to k. Okay. Fine. So basically 4 raised to k plus 1 plus 15 k plus 1 minus 1. How can I write this thing? It is 4 into 4 raised to k,
yes,
okay,
sir.
yes,
plus
sir.
15k
Plus
plus
15
15
minus
plus 15
Minus.
plus 14 it will be, right?
yes,
15 minus 1, it will be 14, right? So what
sir.
can I tell my 4 raised to k? What is my 4 raised to k basically? My 4 raised to k, my 4 raised to k is basically equal to 9 times lambda 1 minus 15k, sorry,
Minus 1
15k
plus
Plus
1.
1.
plus 1, right? So just substitute this thing over here. So it is 4 times 4 raised to k. So basically it is 9 times lambda 1 minus 15k, right? Plus 1 plus 15k plus 14, right?
Yes,
I can do
sir.
this thing? Confirm?
Yes.
Yes,
Okay,
sir.
great. So just expanded, it will be 36 times lambda 1, okay, minus 60k
6k
plus
plus
4
4.
plus 15k plus 14, right? So it is
Yes.
36 times lambda 1 minus 45k plus 18. So it is basically 9 times of 4 lambda 1 minus 5k plus 2, correct?
Yes, sir.
Yes, sir.
Right? So basically, can I say that my p of k plus 1 is also divisible by 9? Because it is 9 times multiplied by something. So I'll
Yes,
just
sir.
assume this second thing to be lambda 2. So p of k plus 1 is divisible by 9. Fine.
Yes, sir.
So that means my p of k plus 1 is true. Okay, please ask your doubt. So if p of k plus 1 is true, p of n is also true.
Sir, can you
For
please
all,
tell me how you get 4k value, 4 to the power k value?
yeah, no worries. I will. I'll just explain your the whole question again. See, what is happening is my p of n is basically 4 raised to n plus 15n minus 1 is divisible by 9. Okay. N is belonging to all natural numbers. So what, first of all, my first step of principle of mathematical induction, my first step is p of 1, proving the first statement. So p of 1. So I substituted n is equal to 1. So when I substituted n is equal to 1, I got 18. So this thing is divisible by 9. So I have proved that my p of 1 is true. After that, what I did is I wanted to assume that my p of k is true. So I just put in any random value of k. 4 raised to k plus 15k minus 1 is divisible by 9. So what we did in our 10th class was that whenever something was divisible by a natural number, so I have this expression 4 raised to k plus 15k minus 1. It is divisible entirely, like it is fully divisible by 9. So I can write it as 9 times lambda, and my lambda will be a natural number also. Because if it is divisible by 9, so this thing can be written as 9 lambda. So what I did was I took out 15k and 1 on the right side. So my 4 raised to k basically got equal to 9 times lambda 1 minus 15k plus 1. Lambda 1 and k both are integers over here. So when I tried to prove
How
my
you
p
get
of k
1,
plus
sir?
1, like I have this 15k minus 1, na? So I took my 15k minus 1 to the right hand side of this expression. So
There
4k,
is
I left
14.
it on the, there is,
Okay, sir, I understood now.
uh, are you sure?
Yes, sir.
Okay, anyways, I was just explaining the question back. So see, I got my p of k plus 1. So my p of k plus 1 is 4 raised to k plus 1 plus 15 into k plus 1 minus 1, right? So I substitute, like I broke it. 4 raised to k plus 1 है. So usko I wrote it as 4 into 4 raised to k. And here from back, I substituted my 4 raised to k as this. So my 4 raised to k, I substituted back. I wrote it back, like I expanded it again. And then when I compressed it, I again got a common factor of 9. So it is 9 into 4 lambda 1 minus 5k plus 1. Lambda 1 is also is also a natural number. K is also a natural number. 2 is also a natural number. So basically it is 9 times multiplied by another natural number. So 9 multiplied by any natural number, can I say it is definitely divisible by 9? 9 multiplied by any natural number, yes, the number is divisible by 9. So I can say that my p of k plus 1 is also divisible by 9. So if my p of k plus 1 is divisible by 9, my p of k plus 1 statement is true. So from my p of k plus p of k, I came to p of k plus 1. So this was the basic proof I needed for PMI, for principle of mathematical induction. This was how I needed to proceed. From P of k, I came to P of k plus 1. And P of 1 was already proved true. So I can say that my P of n is true for all natural numbers. Okay, that's it. So just remember this thing. Like actually not remember, you should actually understand how this is working. So just three steps you need to follow. First, check the first statement is true or the first term is true. Then assume that P of k is true for any k belongs to natural numbers. Then using that P of k is true, just prove it for P of k plus 1. So this is the 3 basic steps of principle of mathematical induction. Fine. So that's it. Since this is not a syllabus of JEE Main, so just one session was enough. If you have any doubt, you can ask. I'm here only. So if anyone has any doubt in whatever was discussed today, please let me know. No doubts? Okay, then that's it. Thank you. Have a nice day.
Thank you,
Thank
sir.
you,
Thank you,
sir.
sir.
Okay, okay. Thank you. Thank you.
Thank you, sir.
Sir, thank you, sir.
Okay,
All right,
thank you.
students. See you in the morning tomorrow at 5 o'clock. 5 to 7 is the class in the morning.
Bye, sir.
Thank you, everyone. Good night.